Okay. Good evening, everyone. I hope all of you are doing well and enjoying the summer analytics journey so far. On the behalf of Consulting and Analytics Club of IIT Guwahati, I welcome you all to the fourth industry session of Summer Analytics 2026. Summer Analytics is a 6-week free certification course focused on data science and machine learning. Through lectures, assignments, quizzes, and industry sessions, the program aims to provide participants both fundamentals and practical exposure to real world AI applicants. One of the most exciting aspects of summer analytics is learning directly from industry leaders who are building cutting edge AI system in the real world. And today we have excellent speaker joining us exactly for that. Today's session is titled Case Study Approach on Building Agentic RAG. Over the past few years, artificial intelligence have evolved from simply answering the questions on performing complex tasks such as searching information, making decisions, or solving real world problems. Two important concepts driving these transformations are agentic AI and RAG, that's a retrieval augmented generation. Simply putting into words is like agentic AI enables AI system to take the decisions and use the tools to accomplish the task, whereas RAG helps the AI system to retrieve the information from the external sources and making it responsible, more tangible, accurate, and reliable. In today's session, we will explore these concepts through the practical case study and see how modern AI applications are built. Just a quick heads up before we begin, the quick reminder for everyone the week 3 quiz is currently live and will remain open till 21 June EOD, that's on today 11:59. Now, it's my pleasure to introduce our speaker, Mr. Tarun Jain. We are delighted to welcome Mr. Tarun Jain, AI researcher at Kaivid Labs, Google developer expert in artificial intelligence, and Qdrant distinguished ambassador. Sir has extensive experience working in Gen AI, agentic system, RAG, and vector databases. He has worked extensively with modern AI technologies, actively involved in educating and developers through workshop, technical talks, and community initiatives. Given today's topic, we couldn't have got a better mentor than you, sir. We are truly grateful to have you here. Sir, the stage is all yours now.
Thank you for that introduction. So I just wanted to confirm: is my voice audible, properly audible to the audience? Because
Yes, sir.
okay, so I hope the organizers will look at the chat, and I'll probably share my screen so that we can get started with the today's session. Can you confirm if my slides are up?
Yes, sir, it's visible.
All right. Once again, thank you for the invitation. It's my third consecutive year for Summer Analytics hosted by IIT Guwahati. When I was at AI Planet, I was usually also moderating the live sessions and also cover most of the EDA and ML based topics. Since the agenda for, the role for this particular IIT Guwahati Summer Analytics 2026 was case study and public approach related. I mean, showcase in public. I thought this is going to be a very useful topic for someone who wants to understand or get into generative AI, because there are some concepts which most of you have already heard of, right? If you just open LinkedIn and see some of the applications that are built, you might have seen some keywords like agents, Gen AI, then retrieval augmented generation. So what we will do today is we'll talk about RAG, the fundamentals of it, on what it is about, and fundamentals of AI agents, tool calling, so that you can get little bit of clarity on what these concepts are about. And once you have all these concepts in place, usually I prefer case study approaches where we understand how companies or startups are using AI and how they are building their architecture solutions, right? So we look at their flow charts, we try to break down the concepts, and we try to replicate it. So that is going to be the focus of today's talk. First, we understand the fundamentals, then look at case study blog articles, take the flow chart in place, and once we have flow chart, we'll try to replicate it. So that is going to be the agenda. And a quick introduction about myself. The moderator has already given us few insights, but a bit more introduction. I work as a founding engineer, mainly focused on the AI research side at Kaivid Labs. We are mainly working into self improvements for agents. And apart from that, it's been 3.5 years now since I'm part of Google Developer Experts program in AI. And I'm also part of Qdrant Distinguished Ambassador. And apart from that, I love contributing to open source. I've been part of Google Summer of Code for 2 consecutive years. In 2024, I was part of Red and Lab, and in 2023, I was part of CM Microscope, and I still contribute to open source. Right. So this is a bit introduction about myself, and a fun fact: I love watching F1, anime, and reading manga. All right. So before we can again proceed next, here is a quick agenda on what we will be focusing today. We start off with fundamentals of RAG and AI agents. Then what we will do is we will cover a concept called function calling. You can also call it as tool calling, which is across most of the blog articles. And when I mention custom tools here, we'll also be looking at how to use RAG as a tool for the agent. So that's where I've written vector store as a tool, right? And then we'll also talk about observability and monitoring, because this is the most important part when it comes to building generative AI, so that you monitor your app and see what goes wrong. And once this is done, we'll also try to break down the architecture behind how Uber is building enhanced agentic RAG. So we'll have the code demo using LangGraph and Qdrant. And there will also be a few concepts like metadata filtering, so that this is just an optional part. You have that in the code. I'll explain it so that after the workshop you can experiment and build any applications using AI. And a bit disclaimer as well before we can proceed next. So since I told we will be referring to Uber's case study article and replicate that particular architecture diagram, so the tech stack that we use might not be relevant to what Uber might have used. So we know that Uber has used LangGraph, which is written in their blog article as well, but the other vector database, LLMs, and the other tools that we use might not be relevant to what they did. But the main focus is to understand the architecture, to understand the concept, and see what tech stack you know to replicate that solution, right? So the focus is solution rather than what they have used, and we are not trying to copy anything, right? So it's just learning process. So the entire session is on the learning and understanding what to implement, right? So all right, with that in mind, before I can proceed, I just want to again confirm if participants are on the same page, and if anyone has any questions before we can start, we can take those questions and then probably proceed. Do we have any questions or anything? Or probably what you guys can do is you can just type S saying that you're following along, so that even I know people are active. You can just type SSS in the chat. I see 2S, but I'm not sure if it is for the session or anything. Is my voice audible, moderator?
Yes, sir, your voice is audible.
All right. So what we'll do is let's start with the session where the first thing is we'll be using retrieval augmented generation. Now, the first question that you need to ask yourself is, why do we need retrieval augmented generation, and where is it gonna be useful? Now, whenever we talk about large language models, right? Let's suppose you have LLMs like Gemini, OpenAI, Claude. They don't have the data of your own knowledge. For example, let's suppose if you ask what is the work experience of Tarun Jain, it will give you the response of someone who is famous with that name. It might not be relevant to you. So if you upload your PDF, then it is able to answer. And when we look at multiple domains, let's suppose finance domain, then you have banking domain, then you have defense domain, they have lots of documents which is saved within their company internals. So if you want to provide those information to ChatGPT, you need to build that particular architecture where you're having a own LLM, but for your own data. It's not fine tuning, but rather it's a knowledge transfer. So let me break it down in simple words. So whenever you're building RAG for very first time, there are two steps involved. One is document processing, which is under the red block, and second is the answer generation. Now let's start off with document processing. When I talk about document processing, we start off with an external data. So the data can be in any format. It can be PDF, it can be PPT, it can be CSV, not CSV, it can be PDF, PPT, or documents, right? Now, once you have this particular documents, the next step is you have to chunk the data. Now, why are we supposed to chunk the data, right? When it comes to large language models, we have a concept of context window. For example, Gemini has 2 million context window. Then you have Claude models with 200K. Then some of the models has 128K context window. So when we talk about context window, it's like how much input and output tokens can you utilize to use that particular model. So if you have a PDF which is of 1,000 pages, you can't directly give that entire PDF to the large language model just like that. So if you want to use as a chatbot, you want to get relevant information, only the relevant piece. So let's take an example, right? So here I took a 2 hours long podcast video. Let's suppose it's a 10 hours long podcast video. Now you have a question from the podcast, which is in the last 10 minutes of the podcast. So do you think the entire 8 or 10 hours of transcript is required to be given as a context, or just the last 10 minutes transcript? So the most preferred approach will be the relevant information. So what we try to do is, once you have an external data, chunk your data so that you give relevant data to the large language model to generate the final response. And second thing is, you don't hit the context window of large language model, because the more tokens you use, the more uh, cost is utilized, right? So more tokens equals to more cost. We don't want to increase the cost of our chatbot. So it's always better use less tokens and get better response. So you have data. After data, the next step is chunk the data. And once you chunk the data, you need to understand the meaning of it. So for example, let's suppose I want to know what happened in the last 10 minutes of the video. So how do I know? I have to get the relevant information. That's where your raw data is converted into vectors, and then you save that in a vector DB. Now what vector DB does is, it has multiple search techniques. So if you want to search anything relevant to finance, if it is related to SEC filings, wherever that is mentioned within your documents, you will only get that relevant chunk, like searching technique, right? So now let's look at an example. Once you save your data inside a vector DB, you have the real-time answer generation where user will ask a question. Let's say you have a podcast video which is saved inside vector DB. It is related to meaning of life, right? So you ask few health benefits which was mentioned in the podcast video. Now after the query, the next step what you're trying to do is you convert that into embedding models. So when we talk about embeddings, it is only vectors, right? So now once you have the vectors, you're looking into vector DB, which also has vectors. Whichever is the most relevant information, you're extracting the context out of it. So if you see 1, then 2, then 3, here in the third step, you get the relevant context. So earlier we had around 25 chunks. Now if you see, only 3 relevant chunks is given to the LLM. Now whatever information you get, you're giving it to the LLM along with the user query so that you can get the final response. So rather than getting more generic response, now what LLM will do is, it will look into your DB, get the relevant chunks, and then generate the final response. So this is retrieval augmented generation in simple words. First step is retrieve, which is retrieve relevant information from vector DB. Second is augment. Augment is basically you're getting query, you're getting context, you're creating a prompt template. Once you get this particular, so if you see 3 is retrieval, 4 is augmentation, where you combine your query and context in a prompt. Then fifth is generation. You're generating the response using an LLM. This is retrieval augmented generation, which we will try to replicate in the upcoming demo as well. Now that you know what retrieval augmented generation is, let's talk about agents, right? How is agent different than an LLM? So when we talk about agents, you might have already known this particular keyword, but let me also give some examples so that you are aware of it. Now imagine yesterday Netherlands and Sweden played their FIFA match, and you want to go to ChatGPT and ask, "Hey, what was the final or full-time score between Netherlands and Sweden?" Now, whatever match happened, it happened yesterday, which is real time. You can't directly use LLM because LLM is trained on specific data. If you want to get the real time information, you enable web search. So now using web search, as soon as you give any user query, ChatGPT will use a search tool, get the relevant information using search, pass that as a context, and then it will generate the response. So it is kind of an agentic solution where you have multiple tools integrated. So based on the user query, one tool will be picked one at a time. So if you see, you have calendar, you have calculator, you have code interpreter, you have search. And based on the user query, one tool will be picked, which is called action. Now, if you look at this entire process, if you ask anything related to time, if you just go to ChatGPT and ask, hey, what is the time now? It might use search, it can also use calendar, but whichever is the most relevant. Now how do we get to know which is more relevant? I'll talk in a bit. Whichever is the most relevant tool, that will be picked, and once it is picked, you have an action. So the role of action is to provide the context. So once you have the context, the next step is you have a planning part. Now what happens in planning? You have an LLM with heavy prompt techniques, like reflection is a prompt technique, you have self critique, you have chain of thoughts. So all these are prompt techniques with bit of engineering. You pass this context within your prompt, then you have LLMs which are very good with reasoning, which will generate the final response. So the major thing is, you ask a user query, agent will pick what tool is relevant. After tool, you get the context, give it to the LLM, generate the final results. Now you might be confused now, right? What is the difference between LLM and an agent? So here is an example. If you use just LLM without any tools, and if you ask good morning, the response will be good morning, how can I assist you today? Now the catch here is, the time is 7:30. So if you ask good morning at 7:30, LLM will not use anything, just its base knowledge. You tell good morning, it will tell you good morning back. Now the same thing, if you give a tool to an agent, so if you ask good morning, now if you look at the response, good evening, it seems it's still night time, but if you are greeting me with good morning, maybe you're preparing for a fresh start. So the thing is same, but the thing with agent is, you have more tools, you have better reasoning. So in this reasoning, what is happening, you have better planning techniques, where you have reflection, where you have feedback technique as well, then you have self critic, where you are critiquing the response and trying to improvise yourself. Then you have chain of thoughts, where you're breaking down your solution into step by step, and then generating the final results. And lastly, you have memory. So we'll not focus on memory for this particular session, because memory itself is a new topic. Now in memory, short term memory is basically within the same session. Now let's suppose you're using a chatbot. Now within the chatbot, whatever questions you're asking, you have a session, right? If whatever previously you've asked, if you want to follow up, that is called short term memory. Long term memory is if you're creating multiple session. Let's suppose after 10 days you're creating a session, and if you want agent to remember your preferences, let's suppose you're traveling to a new country, and you're asking agent to generate a itinerary. Now I'm a vegetarian. Whenever agent creates an itinerary, it should know what are my preferences. So that is long term memory. So these are the four major critical components to build an agent. You have tools, you have action, you have planning, and then you have memory. And this is something that everyone needs to know, like what is the difference between LLM and an agent. LLM is just a base model, an auto regressive model. You have input in, input out, it is stateless. Then you have stateful. So in stateful, you have multiple tools, you have context that you're fetching, you have RAG solution from where you're getting the information. In our case, it is tool calling. Now once you do the tool calling, you get the context, and then agent will generate the final result. Now you might again get confused. Hey, what is this tool calling and how does this work, right? In simple term, tool calling is nothing but if you want to interact with LLM in real time and get the context. For example, what happened in yesterday's FIFA match between Netherlands and Sweden. So how does this work? Now, what typically happens is, whenever you're building tool calling, that particular solution already has a function. So if you see here, step one, you have a developer. He has already defined get weather function, and it has certain parameters. Along with this function, a user will ask a question saying that, what's the weather in Paris? So these two inputs are from the developer. It is going to the model. Now what model does is, it will not give you the answer. It will just give you a function which is get weather, and it will pass a parameter. So now if you see here, the parameter is what's the weather in Paris. No, it is just Paris. So whatever this argument is there, right? This argument is defined by LLM, which is model. Now you have one LLM call. This is very important. Notice this. LLM is giving you a result which is just a function. It is not the response. Now this function is again passed to the developer. You have a sandbox. Now in this sandbox, you are executing the results. Get weather, you have Paris, and the output is 14. Now this will act as a context. This context is given to the LLM, and now that it has a context and user query, it will generate the final results. So how many LLM calls were made? The first LLM call was to get the function, and the second LLM call was to get the final result. Now this is something that you will observe in the code as well. Whenever you are using any tools, LLM will first pick a tool which is your agent, and once it picks a tool, you get the context, and then you generate the final result. So these are the fundamentals. The first fundamental was retrieval augmented generation. The first goal was to save our data into vector db. Once it is saved in vector db, then you can have your Streamlit app or any chatbot app. where you just have to enter the user query, convert your query into embeddings, get the relevant context. Now, LLM has two inputs, query and context, then you generate the final result. This is RAG. Now, when you build an agent will have tools, it will have LLM, which is your planning part, and action is, if you see, it is a dotted icon. It is happening in the backend. The only thing is you have to pass tools, you define a description, you define a planning part, and generate the final result. And lastly, you have tool calling. You don't have to worry about tool calling because tool calling is internally happening when you're using an agent. But this was just to show you how it is happening in real time and how does it work, because you need to know how many LLM calls you're doing when you're using tool calling. Now the question is, how do we define custom tool call? So in order to define custom tool call, I told you, what is the time today? Calendar can also give you the response. Search can also give you the response. But which one will be picked? Because action only picks one tool at a time, either calendar or search. So how do we know, or how do agent knows which tool to pick? That's where, when you're defining a Python function. So for example, let's suppose define search knowledge base. This is a simple Python function. Here the parameter is query and you're defining str. This is called typing in Python. I hope everyone knows what is typing in Python. After you define a function, you have to define a doc string. So whatever you define inside a doc string is the context that is given to the agent. So let's understand this, right? Let's suppose you have search, and apart from search you also have calendar. So when you're defining these two things, you will have define search, then you will have query, then you have str, then you will tell search the, I mean, use Google search and get the results from the web browser if it's real time. And once you have this doc string, you will have your logic. So you have logic. In logic, what will happen? You're using your search API from Google. You define the logic and then you return the results, right? So this is your function one. Then you have def calendar. So in calendar also you define query. Then you have, it is a string. So whatever you, this is there, right? This is called Python typing. This is a concept called Python typing. You might have seen across all the GitHub repositories, right? Let's suppose you open any GitHub repositories. GitHub. Let's suppose I open Cogni. You have this library, API. Let us open a function. So if you see here, you have app, and after app, you have this particular typing. And if I open any functions, where are functions? Here also, if you notice, you have a function, you're defining execution, then you have colon, then you have a type. So all these types are basically Python typing, which is a common practice that we use whenever we contribute to Python coding, right? So now you have def calendar, then you have query string, then again you have doc string. If the user query is related to date and time, look into calendar. Now if you see here, you have calendar, you have search. If I ask, hey, what is the time today? Even though search can give me that result, it will not use search as a tool. Rather, it will use calendar. Why? Because inside calendar, it is specifically mentioned for date and time, use calendar. So whenever you are defining custom function, just make sure you define a function, then define doc string, because doc string act as a context whenever you're using your agentic workflows. Once you define doc strings, then you can define your user query or core logic from where you have to get the context. Then you can generate the result. Now, why am I mentioning this? Because once you start building an agent, you will never use the existing tools. For example, let's suppose you're working in a retail startup In this retail startup, they will have multiple APIs, like getting what is in the stock, what stock needs to be refilled, if there is any product which is out in limit, if you want to stock fill it. There are multiple functions that you have to define, and agent, what it will do is it will try to interact. Hey, is the product available in the stock or not? If it is not, how much should I book it? So all this information is written in a function where you are just getting the context and agent is generating the response. So custom functions is very important once you start building the agents, and this is very important because you need to write good context whenever you define function. And in simple words, it is only string, it is simple English. All right. Now that we have covered three fundamental concepts of RAG, agents, and function calling, which is the core part of the code demo that we will be doing. Now the last part is observability. Now, what is observability? Let's suppose I ask a input or I send a user query for my chatbot. Chatbot generates a final response. Now there are multiple parameters that we are supposed to track. What is the cost of it? What is the latency? How many tokens was utilized? What tool calls were made? And how much time every tool calls took? So all these things needs to be traced. That is called tracing and monitoring. Now monitoring, let's suppose any user is asking bad prompts and you're getting bad results. Now you want to improve your chatbot. So if you want to improve your chatbot, you have to check all these logs, understand where things are going wrong, and then improve your chatbot. That's where monitoring. Now how do you decide whether something is going wrong or not? That's where you have evaluation. So tracing, monitor, and evaluate is part of observability. We don't have to worry much about this. I'll There is a library in just few lines of code you can implement it. So we'll be using OPIK. OPIK is completely open source. You just have to connect OPIK with the function calling that you have, and once you connect it this function calling, it will trace every input and output. So what is traced? uh, if you look at this particular screen, you have tool callings. So you have handle query, then inside handle query you have classify query. So all these things are functions. So here if you notice, it will tell you how much seconds it took. This is latency, and this is called trace telemetry, where you have latency, number of tokens, and also cost of it. And once this is done, you also have user input and model response, like how many emails has she opened in the last year, and you have the final response. So all these things needs to be logged, which is mainly used in observability. And last thing is you have something called as evals. In evaluation, probably this is not the focus of today's talk, but after this session, when we are talking about how Uber built their enhanced agentic RAG, you have a particular column where they showcased on how they built their evals as well, where they basically use something called as LLM as a judge. Now, what do you mean by LLM as a judge? If you give a user query to LLM will generate a response. Then you use another LLM to see if the response is correct or wrong. So you're using LLM itself to correct if the response is right or wrong. So that's where you have multiple metrics like answer relevance, hallucination, then context precision. So when we talk about RAG, you give a user query, you're getting the context. Is the context relevant or not? So that is mainly defined by precision and recall. But if you don't want to use LLM, you also have heuristic metrics which are rule based. So for example, rejects, right? You define a pattern. If the output is following that pattern, then you can evaluate it. So that is where you have heuristic metrics. Then also if you're building chatbot, you have conversation metrics. But the major focus across most of the RAG and agent solution is LLM as a judge. That is using LLM itself to judge the response of LLM. All right. Now that we have spoke about few concepts, if anyone has any questions, we can take those concepts and then we can proceed how Uber build their enhanced agentic RAG. So in order to understand this particular next two slides, you need to know what is RAG, you need to know what is agents, and you need to know what is function calling, because these three are important. Do we have any questions? Yeah. How do you handle ambiguous or incomplete queries in the RAG system to ensure the relevant results? So here, what typically usually you can do is you can use query optimizers. Now I'll talk about query optimizers as well. So let's proceed with this particular part. So Now the next thing is we have enhanced agentic RAG, where this is written by Uber. Now this is the article. Let me open this article. So there are two parts here. So the first part is you have document processing. Let me give me one moment. Just give me one moment. Is there any noise from my side? Is there any background noise?
Yes, a little bit.
Okay, I don't know why people they're burning crackers. I'm not sure. Now is it fine? Now is there
Yes,
any
now
noise?
fine.
Okay, so I'll share my screen again. So what we'll try to do is let's try to understand how Uber built their enhanced agentic RAG. And here I will also cover that particular question on how to tackle the ambiguous or incomplete user queries. There is something called as query optimizers where I'll cover it here. All right, so let's go step by step. Now what Uber did is they built something called as Slack chatbot. And this Slack chatbot name is Jenny, right? So what is happening is user asks a user query. Uber has multiple policy documents. So all their PDFs is saved into a vector DB, and then you're asking the question. So now if you see here, the first thing is you have knowledge documents. After knowledge documents, you're creating custom metadata. This is the first step. So let me tackle first problem statement, which is custom data, custom metadata. Now, what is the importance of this? Assume you're working for a finance domain and you have around 100 PDFs. So now what you're trying to do is you're saving this 100 PDFs inside a vector DB and you're using this for a chatbot. Now, when you're building a chatbot, let's suppose you have a chatbot, and in this chatbot, you ask a user query. So this is user query, and you have a model response. So you ask a user query, you're getting the model response, but how do you make this better? You can make this better by telling from which source the response was generated. Now you have 100 PDFs. So if you tell user, hey, this response was generated from this particular PDF. So that is called source from which the response was generated. You can tell the path of the PDF. And second, you can also tell from which page number it was generated. So now what people can do is they can verify whether the response is correct or wrong by going to that PDF by checking the page number. So you can just imagine out of 100 PDFs, you're reducing that down to one or two PDFs, and then from one or two PDFs, you're reducing it down to specific page number. So this is metadata. Now, what do you mean by custom metadata? Now, assume whenever you are working with any large enterprises, you will have PDFs across multiple domains. It can be something related to manufacturing, it can be something related to finance, it can be something related to product. So there are multiple keywords, right? So assume you ask a user query, but this user query was related to product, but it is also overlapping with manufacturing. It is also overlapping with two different domains. So what chatbot will do is it will use manufacture, which was in the top PDFs, and it will give you that context. Even though the context as per the meaning it is correct, but it is still wrong context. Why? Because you wanted something related to product. So what typically we do is, apart from source and page number, which is your metadata, you also create summary. You create a summary for your chunk. Whatever chunks you have, you create the summaries for it and save it across every chunks. Then you also have document summary. Now what is this document summary? Let's suppose you have 5 PDFs, and this 5 PDFs gave you 30 chunks. Okay, I'm just taking a simple math. You have 5 PDFs, or let's take 300 chunks. At the end of the day, all these 300 chunks only belongs to 5 PDFs, correct? So PDF 1 has around 60 chunks. I'm just taking rough math. Your second PDF has 80 chunks. Now, what is happening here is when you look at this 60 chunks, you will have metadata. Now, this metadata will include source. Now, this source is nothing but one.pdf, right? My first PDF is one.pdf. Then you will have page number. For example, chunk 1 will be 0, then chunk 2 will be 2, then chunk 3 will be page number 3. So every single page is one chunk. Now, what we do is, apart from source and page, we create document summary. So this document summary will be same across every single chunks. So you understood what is happening? You have 60 chunks from one PDF only, correct? So since it is from one PDF, all these 60 chunks will have same document summary. That is called document summary. Then you have chunk summary. Now what is chunk summary? Every 60 chunks. So chunk 1 will have its own summary. It will have its own summary. Then 2 will have its own summary. So chunk summary is different for every chunks. Document summary is same for every single chunk for that particular PDF. So this is one extra metadata. This is another extra metadata. Then you have keywords. Now, what is this keywords? If it belongs to manufacturing, you will have manufacturer. If it belongs to product, it belongs to product. Now, using this metadata, what happens in chatbot building is you can filter it out so that you can get right results. This is what these folks did. So if I just search for metadata, so if you see here, for metadatas, we incorporated document summaries. So what is document summaries? If you have 5 PDFs, for every PDF, if you have 60 chunks, every 60 chunks will have same document summaries. Then you have set of FNQs. So they created frequently asked questions for those particular chunks so that you can improve your retrieval process. Then you have relevant keywords. This is very, very, very important because we use keywords a lot. Whenever you are working with PDFs, there are multiple domains: manufacturing, product, HR. If you want to filter it out properly, we define metadata, which is relevant keywords. So this is what I was talking about. The first problem statement is add custom metadata for your data so that your retrieval process is improved and you can use filters. So what is the drawback of this? Better retrieval, and second is you can use it for filtering. All right. So this is first problem statement. Let's go with the second problem statement. Now, once you ask a user query, for example, let's suppose once you have custom metadata, they have multiple tables. So they are chunking based on the tables. Once that is done, you're using embedding. So far, we are on the same page. If we come back to our slides, you have data. After data, what are you trying to do? You have custom metadata while creating this chunk summaries. And once you have chunk summaries, you also have embedding model. Now, once you have embedding model, you have to save it in a vector DB. Now, when you save it in a vector DB, they are using something called as hybrid search. So if you see here, you have something called as vector search. You have something called as keyword search. Now, let me simplify this in simple words. So I'll come back to my slides. And there is one slide where I've talked about how hybrid search works. For example, let's suppose your user query is neural network. Keyword search, what it will try to do is it will only find those relevant context. I mean, it will only find those context or chunks which has neural network. If it doesn't have neural network, it will not return. So what keyword search does is it will only map relevant keywords, mapping. Now, if you look at vector search, if you search for neural network, it will find neural network. It will also find deep learning, AI, machine learning. Why? Because in a semantic space, neural network, AI, deep learning has similar meaning, right? So that's where vector search is on meaning. Keyword search is based on matching. So how does this work in technical terms? Second, second problem statement is uh, using better search, where we are using hybrid. Now, how does this work? First, you have keyword search. Now, keyword search, we use something called as sparse vectors, and there are few research paper where you will call keyword as lexical search. So lexical and keyword are the same. It uses sparse vectors, and it is mainly for matching. And then you have vector search. Vector search is basically your dense vectors, and this is mainly on meaning, which is your semantics. And you also use distance measurement, where it's basically cosine similarity. It's for getting, let's suppose, how well your two documents are in the same direction. You're checking the direction. If both are in the same direction, that means it is relevant. So in order to measure that direction, we use cosine. In order to improvise or speed up the process, we use hnsw. This is mainly indexing process, but if someone is interested, they can learn nlp, and all these things will be covered inside nlp. But in rough level, whenever we are using vector database, we will be using hybrid search as our approach. So that is what is used here as well. Now we completed with document processing. Once document processing is done, we come back to answer generation. Now, in answer generation, what happens is, as we user, we will not write better prompts. We will add incomplete queries, which was one of the question in the chat as well. So what Uber did is, they use a small LLM. If you notice here, they've used large LLM for final answer, but for query rewriter, what they have tried to do is they've used a small LLM query. Now, once you give a user query, whatever is the relevant source identifier, they have a custom prompt, and they're rewriting the user query so that you can get better results. So if you see here, you have query optimizer, then you have source identifier. Now, what does source identifier mean? You're modifying your user query accordingly to your metadata, so that when you're using search, you can get relevant search results. If the user query is not in the context, then it will tell no source found. So that's where, in order to keep this very fast and not to have more cost, they've used smaller LLM. So once this is done, you use metadata filtering, which I spoke earlier as well. Once you have information, in order to improvise the better results for the given user query, you apply filtering, and then you use search. Now, once search is done, what is the next part? You get the relevant chunks. It's similar to what we saw here. So if you see, once you have a user query, you convert that into embeddings. As soon as you come out of vector db is where search is happening. So if you check here, this entire thing, vector search and beyond 25, is happening inside a vector db. Vector db will give you retrieved chunks. Once you have these retrieved chunks, if the response is correct, you're doing certain post processing, and once you check that particular post processing, you have the final answer generation. Once you have this answer, you're giving it to the Slack chatbot. Now, answer generation is something that happens real time. Whatever document processing is done, it is happening offline. That means, even if it takes 1 hour, 2 hours, just save your data. Once it is inside vector db, then use it for the chatbot. So that keyword is also there. So if I just search for offline, so if you see here, like RAG architecture, it consists of two key components. One is offline document processing, and second is real-time answer generation. So in offline document processing, how many PDFs you have, you're saving that PDF inside a vector DB, then you're using it for answer generation. So it's similar to this block. So whatever inside red block is there, it's a design approach where even if it takes time, it's completely fine. Your goal is to save that inside a vector DB. Once it is saved here, then you can use it for answer generation. That's it. Now, last part is you have evals. For time being, for this particular session, we will keep evals outside, because this again is a complete new topic. Why? How do we create this data set itself will take time. So probably, if time permitted, you can watch some video. I have the resource here as well on how to evaluate, but we'll come back to this later. All right. So now that we know how the architecture looks like, our main focus is to replicate what you call hybrid search, so that you understand how you can improvise your retrieval process. And there are also some research techniques as well. Like, for example, once you give user embeddings, you have dense. Now, what is dense? vector search. So if you notice these keywords, dense is basically your vector search, which will give you the meaning. Sparse is basically keyword search, which will give you matching. So if you see here, you have dense embeddings, which is for vector search. Then you have sparse embeddings, that is for keyword search. If you combine both of these two things, you have hybrid search. And there are also few people, if you want to re-rank, you use something called as late interaction embeddings. Now, why do we use late interaction? It is mainly for re-ranking, and you have a concept called cold BERT. It is for contextual understanding. It's like contextual understanding, late interaction BERT. So you can just search for cold BERT. It is mainly for contextual understanding. It's a late interaction BERT model. But again, this is not focus of our talk. If someone wants to, if someone is already building RAG, and if you are looking for future, this slide is only for those who knows RAG, right? You might already be aware of hybrid search, but if you're looking for an option of re-ranking, then you have something called as late interaction. All right. So this was the last slide. Now what we will do is we'll directly get into the code demo. Now what I said was related to late interaction, but you also have early interaction and no interaction. For that, you can read out this documentation. I'll keep this documentation for 1 or 2 minutes. I mean, 1 minute, so that you can quickly scan it out. And now we'll get to the code demo. So if organizers and moderator can send the collab notebook to the audience, we can get started with a demo. But before demo, we can take few more questions if there are any questions. Okay. So meanwhile, what we can do is we can just send this particular collab notebook. And just to revise, the major focus is RAG and agent. So whatever code we write here, it's pure Python, and you don't have to worry about the syntax. It is mainly instantiation, define it, and use a function. If there is any new apart from these three, what you call three steps, I will explain it in the drawing board. Then we will proceed with the code. And just make sure as soon as you get collab notebook, create a copy of it. Don't run in the same collab. So in order to create it, click on File, go to Save a copy in Drive. So I'll repeat. As soon as you get collab notebook, click on File, save a copy in Drive, create a copy, then start running over there. So it will tell you to open in a new tab. Open in a new tab. And here you can name it anything. You can just give your name, and then you can tell case study or whatever. So I'll just close this. This was just a copy. And I'll repeat again. Click on File, click on Save a copy in Drive. It will show you a window. In that window, you just have to click on Open in a new tab. Do we have a question? Okay, what we'll do is we'll take questions after the code demo, so that along with slides and as well as code demo, if they have any questions, we can take accordingly. All right, so I'll start with the installation. Just run this particular installation steps. Until this is running, what we can do is we can get our API keys. So click on this first URL, which is Qdrant API key, and then it will show you redirect notice. So just click on this. What I will do is I will run this particular cell in a different browser because I've already logged in here. Cloud.quadrant.io. So as soon as you open this link, it will tell you to sign up. So what you can do is you can sign up. So just click on Qdrant API key, and it will give you this URL, which is cloud.quadrant.io. Use this URL. And as soon as you use it, it will show you this window where it will showcase create a free cluster. So I'll wait for 1 minute until we are all on the same page. So you can just confirm how many of you have signed up. Are there any techniques for chunking or any optimization techniques? Yes, you have something called as schematic chunkings. Schematic chunkings plus custom metadata are mainly used for optimization and to get better results. So you can check out schematic chunking. And we also use parent child chunking. There is also something called as parent child chunking, but I'll not recommend this because it's too complicated and it adds of too much of tokens. So I'll just remove this as an option. Schematic chunking is something that you can explore. Can you guys confirm if we are on the same page, if you are able to log in? Okay, I see two yes. Okay, both the two yes is from the same person. I'll wait for 30 more seconds. Just click on Quadrant, sign up, and you should see create a free cluster. Now, before we do anything, right, we should be asking like, why are we doing this? So why are we using Quadrant and why are we signing up into cloud? So whenever you're using vector search engine, it can be anything. I'll also give you other options as well. So Quadrant is what we are using. The other options, what you can do is VV8 is open source, you can use it. Then you have Milvus, right? And there are few people who also use Chroma as beginners. Now, what you have to do is there are three ways you can run it, right? So the first way is using cloud. So when you use cloud, you will be given a endpoint URL. So what is this endpoint URL? Let's suppose you have AWS, you have GCP, you have Azure. Whatever data you have, it will be saved inside this endpoint URL. And then you will also be given a API key so that you can access this particular endpoint. So you have endpoint URL, you have API key. These are the two things we need to get from this cluster. Now, what is the second step? Second step is if you want to run it locally. So in order to run it locally, you need to have Docker. And once you use Docker, instead of endpoint URL, you will have a local host and no API key. No API key. So this is the second approach. Third approach is in memory. Now, what is happening in memory? Within your project directory, you're saving a particular folder and all the data it is saved inside that folder. Now what happens in Docker? It is across all the folders. In memory is only that folder. Now for example, if I use in memory in Collab, after internet goes off, that data is also gone because that data is saved in Collab, and Collab only runs when you have internet on. So if internet or my runtime is disconnected, all the data is gone. That is in memory. So what we are doing now, we are using cloud so that our data is saved in endpoint URL and we can also access it with API key. So what is our goal? Our goal is to get these two variables. So I hope we are on the same page. So create a free cluster, give a name. I'll just give it as CACIITG, and you don't have to change this anything. So as you can see, by default it is hosted on AWS and it is on the region Ireland. Just click on create free cluster. That's it. Give a name, create a free cluster, and we are done. So you have your API key, copy this API key. Notice starting two letters will be EY. So copy this API key, come back to Collab. Here, if you notice, Qudrant API key, I have added it as user data.get. Why? Because I've already saved it in the secrets. So Collab has something called as secrets. Inside this, you can define a name, you can give a key. So my case is already saved and I don't want to showcase my API key to the user. That's why I've created it as user data.get. But since you're not showing your API keys to anyone else, you can remove this particular variable, directly create a string, paste your key here. So whatever key you have copied, just paste it here. Qudrant API key is there, right? Just create a variable and paste it over there. In my case, I'm using user data.get. Why? Because I don't want to show the API key. But in your case, you can directly paste it here. I hope you understood it. Now let's come back to Quadrant URL. Now for Quadrant URL, if you copy this is just a URL, but we also need a port. So what you can do is remove this user data.get, copy your endpoint URL after quadrant.io, just write 6333. So if you don't want to write this, better what you can do is, after this is done, just copy API key. You will just click on continue, and here you have quick start guide. Let me remove this. Okay, the code is not here. Okay, it's fine. What you can do is copy this endpoint URL. After you copy this endpoint URL, just add colon. After you add colon, just add 6333. That's it. I hope these two things are in place. The first thing is you need to have a API key, which is EY. It starts with EY. And second thing is you need to have endpoint URL. Endpoint URL will stop at IO, but since we are using it in the code, we also need to add port. So let me know if this is done. I'll wait for 1 minute. The only two things you need is endpoint URL and API key. Endpoint URL, just copy this and add a port. That's it. Port is 6333. And API key, it starts with EY. Copy that, paste it. Okay, I'll wait for 20 more seconds. Meanwhile, to those who have already completed, click on second URL, which is Comet API key. Now, once you click on that, just sign up. Sign up using Google. And I'll tell what and why we are using Comet. So it's basically for OPIK. I hope it's done. You just have to create a free cluster, get your API key, and get your endpoint URL. After endpoint URL, just add a port number. All right. So the next thing is click on Comet API key. Again, click on this URL, the starting URL. Now let me explain you why we need this. Um, Whenever you are working with apps, there will definitely be user queries. There will be output which will not go as per your choice. There might be user prompts which are very basics. There will be response which are empty. There might be context which is not properly retrieved. So if you want to monitor it, if you want to trace it, and also if you want to keep track of your costs, right, like, yeah, how many user queries are going above threshold. So if you want to keep all those things in track, that's where we use OPIK. For example, for trace telemetry, then all the user logs, then to keep track of the tool calling part. And once you have all this user data, if you want to improve your code, you can also have something called as self improvement using OPIK. There is something called as OLI, which I'll show in a bit. So in order to have all these details, we use OPIK, which is completely open source. So you can just search for OPIK, GitHub, and it is open source. So just click on this URL, and as soon as you click on this URL, let me open from a different browser again. Let me open from a different browser. Okay, I've already signed up. Let me sign out. So as soon as I send you that URL, it will show you this window. I hope we are on the same page. Are we on the same page, the sign up page? Okay, I see yes. Now what you can do is, as soon as you click on OPIK, which is comet.com, you should see a particular sign up page. Continue with Google. And you are inside a dashboard. Now let's come back to the code. What do we need here? The first thing what we need here is OPIK API key. The second thing what we need is OPIK workspace. The third thing what we need is OPIK project name. The starting two things are very straightforward. How do we get this OPIK API key? As soon as you sign up inside, on the top right hand side, you have your profile icon. Click on this profile icon, and here you have API key. So just hover on this and copy this API key. So copy this, come back to your collab notebook, remove user data.get and paste your API key. Whatever API key you got it, just paste it here. I'll repeat. As soon as you sign up, open your dashboard. On the top right hand side, you will see your profile icon. There you have API key. Just copy this, paste it here. That is first step. So we did the first step. Now the second step, workspace. Now why do we need workspace? There might be times if you are working with different customers, you need to have different workspace for every single customer, right? But what we will do is we will go with the default. Now what is the default? Whatever name you are seeing here. So as soon as you click on your profile, you are seeing Tarun Jain 3091. In your case, as soon as you sign up, if you have signed up using Google, whatever your name is there, that name itself is a workspace. If you have signed up using GitHub, whatever your username is there, that username itself is your workspace. If you want to create new workspace, you can create it, but we don't want to create it. We will go with default. So just copy this particular name and paste it here as a workspace. Either you can copy it from here. So if you see, you have Tarun Arjun here. If not, click on profile, you have it here as well. It's better to click on profile and copy it from here. I'll repeat, OPIK API keys from the dashboard, directly get it. OPIK workspace is your name. Just make sure you change this and don't use what I have added. So I'll just undo it. These two are very straightforward, OPIK API key and workspace. Let me know if it is completed. Then we'll proceed with project name. And also just make sure don't see the code below. And I'm pretty much sure since you guys are coming from ML and deep learning, there are some piece of code which will be completely new. Wherever I feel it is completely new, what I will try to do is I'll break it down and make you understand what is the need of it and how to use it. Once you know the use and syntax, then these days it's very easy to code. You have LLMs, you have Claude to help you with coding. The major thing is understand what is required, understand the keywords, because everyone vibe codes. But if you need to get better results from vibe coding, you need to have better keywords and you need to know what algorithms to use. So that's where understanding the need and understanding what has to be used, understand the keywords, understand the syntax, then vibe coding will become easier. So is it done? I hope you got your workspace and you also got your API key. The next step is you need to get a project name. If you notice on the top left hand side, you have project. Just click on this project. You have a drop down. So if you notice, you have project on the top left, then you have a drop down. Click on new project. And as soon as you click on new project, just give a name. In my case, I just gave it as Summer Analytics 2026 IIT Guwahati live stream, and then create a new project. You can give any name, you can give any description, but what we need is whatever name you have defined, just copy that. In our case, it is Summer Analytics 2026. Copy it and then paste it here. So once this is done, we completed Qdrant API key for VectorDB. We completed Comet API key for observability. And last but not the least, we have Google API key. And I hope everyone knows why we are using this. We are using this for LLM. Can anyone tell me the latest LLM model of Google? I'll tell organizers to gift these folks at least a stickers or anything. What is the latest model of Gemini? So API key is done, workspace is done, project name is just click on this drop down, create a new project, give a name, give a description. So OPIK is done, Qdrant is done, Google is pending, and we are using Google for LLM, which is Gemini, but which is the latest model? It's correct, it's Gemini 3.1, but to be precise, it is Gemini 3.1 Flash, right? So we'll be using 3.1 Flash. But if you ever want to know what are these model names, you just have to open aistudio.google.com. just click on this URL. You have Google API key, just click on this. It will open AI Studio. So first let me go to AI Studio. If you notice this dashboard, on the top left hand side you will have the model names. Okay, Gemini 3.5 Flash is also released. You have Gemini 3.5 Flash, then you have Gemini 3.1 Flash Lite. So all these things are models. You can't directly tell Gemini 3.1. You have to use the same models that is specified here. So you have Gemini 3.5 Live Translate Preview, Gemini 3.1 Flash Lite, then you have Gemini 3 Flash Preview, Gemini 3.1 Pro Preview. So all these things are model name. Now, how do we create an API key? What you can do is, in the Google AI Studio, bottom left, there are 4 buttons. The first button is for the notification, then you have settings, then you have search, and then you have get API key. So you just have to click on get API key. So I hope everyone are on the same page. You have aistudio.google.com, then you have API keys. Let me just copy this, paste it here. So you have aistudio.google.com API keys. Here what you are supposed to do is click on create API key. And since if you don't have a new project, you have to create a new project. Just give it any name. I'll define it as Summer Analytics. Define it a new name. Create a project. And if you want to edit this name, you can edit it. If you don't want to edit it, you can just keep it same. Just create a new project, give a name, and click on create API key. So whatever this is there, the API key, just copy that. Let me also delete it since I showed it live. I'll delete this key. But I hope you understood. What you are supposed to do is just create API key. As soon as you create API key, you have to create a project. If you already have an existing project, use an existing project, give a name, and it will show you a API key. So the starting 2 letters, either it will be AI or it will be AQ. So copy that, come back to your collab. Here, just remove this and paste your API key. And once this is done, we are set up to proceed next. So let me just undo all this so that I'll use my own settings. And once the installation is done, I will clear this output. Then I typically do restart session. And now what you have supposed to do is just run this cell. And I hope you have directly defined your API keys into a variable and you're not using user data.get. If you are using user data.get, you have to save it inside secrets. So key you are directly pasted from Qdrant. URL, paste that URL, add a what you call port, which is 6333. Then we started with OPIK. OPIK is basically on the dashboard. You have your API key. Then this is your workspace. Then create a project, give a name, copy this Summer Analytics 2026 and add it here. Then we created Google API key from AI Studio. If you have completed all this, then we proceed next. We start off with offline document processing. So the first step in offline document processing is to have our own data. So for data, as I said, we will be going with finance. And there is a concept called SEC filings. There is a concept called SEC filings. Most of the companies, they file SEC filings. Now, what are these documents? After every quarter, after 3 months, then after a year, what that particular company has achieved, what they have done, if they acquired any startup, how much revenue they made, if they want to share that information to their shareholders and as well as to the public, they typically use something called as SEC filings. That's where in our core demo, we will be using Netflix SEC filings. So this is the URL, SEC filings of Netflix. You have multiple documents. So these documents typically contains 8K PDF, then you have 10K, then you have 10Q. So these three are some of the documents that typically you define. You make it public for the shareholders and you can read it. So here you have 8K. And if you check for the few more pages, you should find 10K and 10Q. So if you see for annual fillings, it is 10K. Then for quarterly fillings, it is 10Q. And then you have annual, quarterly, then you have current. So in current report, you have 8K. So these are the three documents. If you look at my GitHub repository as well, which is data.git. So if you copy this and paste it here, I have already created two folders. Inside SEC filings, you have 10k.pdf, you have 10q.pdf, then you have 8k.pdf, then you have some shareholder letters. So shareholder letters are written by the company for their investors to share whatever they have achieved. So all these things are public. You can just download it. So what I'm doing is I'm just git cloning it so that all the data is saved inside my project folder. So if I refresh this, you have data. Inside data, you have SEC filings, and then you have shareholder letters. So this is what we need, right? So once you have the data in place, let's start off with the first step. So what is the first step? The first step is to extract the raw information from PDF, then chunk it. After you chunk it, create an embeddings and save it in a vector DB. So here we will directly load it from the folder. Then we use something called as PyPDFM. Now people might ask, hey, why are we using PyPDFM? There is a research paper here. So let me open this. So if you have worked with Python and if you have worked with PDFs, there are multiple libraries, right? So if I scroll below, so if you notice, there are different parsers. You have PDF Primer, you have PDF Plumber, you have PyMU PDF, you have PyPDF, you have PyPDFM, then you have unstructured. All these things are frameworks, right? You use to extract the data. I mean, you use it to extract the raw content from PDF. So if you notice the score, since we are using financial documents, the accuracy score for PyPDFM is more. Precision, the accuracy is more. Blue score precision is more. I mean, Blue score has more for PyPDFM. Then local assignment score is more for PyPDFM. So that's the reason why we are using this particular library. So just run this cell. It will take some time. And here, as I said, we will directly read it from data. So data is the folder. So if you notice, data is the folder. Inside that, how many our PDFs you have, load all those PDFs. So you're defining that condition to load all the PDFs. Then how do you parse it? Parse it using PyPDF. So what do you mean by parse? Parse is nothing but extract the raw content. So that is what you're trying to do. And if you notice a pattern, it is just import statement. After you do import statement, you do instantiation. After instantiation, it is load. So the same thing will be followed for chunking. The same thing will be followed for LLM. It will be followed for embedding. Only vector DB will be different. So you just import. First step is import. Second is instantiate. It's simple, call that particular class and then use a load function. Once you use the load function, you're able to extract the pages. So now if you see across 1, 2, 3, 4, 5, across 5 PDFs, we have 167 chunks. And you can also check the metadata. In the metadata, the only important information for us is source and page number. So if you see, this is the page number. Total pages for this document is 20. You have source, total page, and page. We will remove all these things in the upcoming part of code. But for time being, just understand you have page metadata and you have page content. So what is page content? Whatever information is there, text information in that page, it will be added as a page content. Then you have metadata. You only have two keys. So if you just print this thing out, so if you see, you have a document. Inside this document, you have metadata. And apart from metadata, you only have something called as page content. These are the only two things. Metadata is nothing but source and page numbers. Page content is the raw information. I hope the first step is done. the first step is just extract the raw information from the PDF. Second thing is custom metadata. Now, what are we trying to do? In custom metadata, if you notice this particular PDF, so as per the blog article written by Uber, for custom metadata, we incorporated document summaries, then frequently asked questions, and few keywords. So in our case, we will create summaries, but what I have done is I've commented it out because this will take time to run. So I will just run this particular cell, and then you also have summarized chunk, and then you have add documents. If you look at update metadata, I have commented this code because this will take some time when we run it live. So if you are trying it out, what you can do is you can just uncomment it and then run it by yourself. And I also added generate tags and FAQs. This is something that I want you guys to figure it out yourself so that you will be more involved in this project. So what you are supposed to do is generate tags and FAQs, create a new cell, and use an LLM to generate frequently asked questions. That can be a very good assignment, because the better way you can understand the workshop is also try something by yourself. So this is something that you have to try. So I've added it as comment. It's completely fine if you run it with comment, the code will work. The only thing is, if you want to have better performance, then you can use summary and frequently asked tags. So let me skip this part. You have summary tokens, then you have add doc type. So this is a very important parameter that I need. For example, if there is any 8K, for example, if my source wherever it finds out 8K, I will just replace it with 8K filing. It's a keyword. If it sees 10Q, it should replace it with 10Q filing. If it sees shareholder, it will replace it with shareholder letters. So I will add this as my metadata for keywords. So now I will just click on this update metadata. And if I run this, if you notice, you have a new metadata, which is doc type. In doc type, you have 8K filings, and it is mainly dependent on source. So what did we do? We created a custom metadata. Now, the major purpose of showcasing this is your metadata is a dictionary. So whenever you want to add a new key for your dictionary, you can directly define chunk metadata, your key name, and the value. So I hope you know the syntax of this. Dictionary, then key equals to value. Once you do this, you are creating your new metadata. That is what we did. We added doc type. Now what we are supposed to do is, we only want to keep source, total page, and doc type. So remaining all the metadata, I don't need it, so I will just remove it. So far we have completed two steps. The first step is extract your raw PDF chunks. Second is create chunks and add custom metadata. So as per this architecture diagram, we have completed this particular part. We have completed this part. Now we just have to complete this vector search. Once we complete this vector search, part one is done, which is document processing. Then we are just remaining with part two. Part two is very simple. So if we complete this, we have completed almost 60 to 70% of the code. And as I said, we'll quickly wrap this up. For fast embeddings, this is the embedding model we will be using. You have text embedding. Text embedding is basically for dense vectors. Now, dense vector is for vector search. Then you have sparse text embedding. This is mainly for, it's in the name itself, it's called sparse. This is mainly for keyword search. By combining both of them, we will be using hybrid search, and there is a concept of fusion, RRF. So whenever you have hybrid search, how do you want to rank it? How do you want to merge it? So that's where we use this fusion technique, which is reciprocal rank fusion, which is again natively used in Qdrant. And once this is done, we just have to instantiate it, define our Qdrant client, and then define configuration. So just run this cell. So now what are we trying to do? First thing is, We are trying to create a space. First, we create a space by defining the configurations. So what do we need to configure? We need to configure what are the dense vectors. uh, Here basically you define the dimension and distance measurement, and then you have to define sparse. So once you configure it, then you can save the data. So first you configure. Once you create that particular space, then your data is saved here. So first create that particular space, then configure, then push the data. So in order to push the data, we use upsert, and every single data, it is added as points. So what are these points? It's basically your vector and payload. So whatever document page content you have. So if you notice, if I scroll above, so if you notice here, docs has two things. One is page content, where you have raw data, then you have metadata, where you have all this information. So all this information is used for filtering. So if it is used for filtering, it is mainly going in payload. This is mainly for filtering. So you add your metadata. There are only two things. One is page content, which is to vectorize to get the relevant meaning. Payload, it's for filtering, where you are just adding your metadata. Then you have id. So id is nothing but unique information. For every chunk you will have its own unique id. So it's just uuid. So what are we supposed to do? Create a space, configure. Once you configure, add your data. How do we add it? Using upsert. And when you do upsert, you have to define a collection. Like every data only needs to be saved once. If your data changes, you just have to change your collection name. And then you have points. Inside these points, just define vector, payload, and id. If you know all these things, no matter what vector database you use, it's the same thing. Create a space, configure, push the data. That's it. So let me start with the first step. We are creating a space which is Qdrant client. It is already on the cloud. So just run it. You have URL, you have API key. The next thing is you are running collection name. So collection name is case study. And then you have dense model name, which is Gina. This is the dense embedding model. And sparse is nothing but BM25. So if you come back to this blog, if you see, you will see this particular keyword BM25. Then for vector search, you can use Gina embeddings. So this is just embedding models. And how do we get to know these names? Just search for supported models fast embed. So let me search for it. Supported models fast embed. If you see here, you have Gina AI, Gina embeddings v2, small en. Just copy this, paste it here. That's it. And now what are we trying to do? We are creating a space. In order to create space, you have to define configuration. So the vectors configuration is dense. You are supposed to define cosine and then define a embedding size, which is 512. So if you see, it is 512 fixed. And then you have sparse. So in sparse, what are we trying to do? We are just defining an identifier, which is idf. This is mainly for keyword. Once you do this, it will show true. In my case, I've already created it. So if I open this particular cell, so if you notice the keyword, my collection name is case study. So case study is already saved and you have around 167 points. So this 167 is basically the length of chunks. So if I print length of chunks, it is 167. Those are already saved. So that's the reason why I will not run the cell, but in your case, you can run it. It should show true. Once you do this, you are supposed to run upsert. What are we supposed to do in upsert? Just define collection name and points. In points, you have vector, you have payload. So in payload, what are we trying to do? We have source, page number, page, doc type. It is just using payload, and here we are just using vectors. That's it. Once you do it, it will push all the changes to your vector cloud, and here you should see this number. So if I come back to the cloud and click on cluster UI, you should see this number, which is 167. If you are able to see this 167, that means your data is pushed. Now what we'll do is I'll just test out that particular vector DB that I had, add a user query, mention the success information of K-pop demon hunters. This was written in the shareholder letter. And I want to get top K3. So I have 167 chunk. Out of 167, whichever is the three relevant chunks, get me those three chunks. So run the user query. Now what are we trying to do? We are using hybrid search. So first you need sparse, then you need dense, and you are getting three information from keyword search, three from keyword, three from vector. And once you do that, just combine it. How do you combine? Using fusion. So in this fusion, we are using something called as RRF. This is the only two parts where you will feel, okay, this is something new. But if you look at the pattern across all the vector DB, it is the same, right? You define your configurations, dense and sparse. Once you define those two things, you just have to use search. So the function for search is query points. Once you run this particular cell, it will give you the search results. You have total three relevant documents. Why is it three? Because I defined it as top K to be three. And then if you just search this, you will get the relevant information. So in this relevant information, you have something related to K-pop, and this is the chunk that will be going to the LLM. So far, we have completed step one, which is document processing. You can also filter it out. So whenever you filter it out, you have to define your metadata, which is source. Then if you see match, you should only extract those information which is across shareholder letters. If the information is not in the shareholder letters, don't give that particular PDF. This is mainly used for filtering. So first you create a payload index, then give the information, and then only you will extract the information. Here, if you notice, if I give 10K, if I give 10K filings, it will be zero. Why? Because this information is not there in the 10K. So that's the reason why it is zero. But if I undo this, and if I tell to search from shareholder letters, it will give me the relevant search results. But filtering, again, it's a optional topic I wanted to showcase. But if you don't want to try it as of now, you can keep it for future purpose. The main purpose is to understand RAG. Extract your raw information, chunk it, create an embeddings, and save it. That is what we did. And this is the last part, which is answer generation. So for answer generation, what are we supposed to do? Coming back here, we completed three, which is retrieval. And the second part is augmentation. What is happening in augmentation? Take your user query, take the retrieve context, create a prompt. You just have to build a prompt. So this is the prompt. You have system prompt, you have user prompt. So here, if you notice in user prompt, you're defining your context, you're giving your user query. Now, what is system prompt? This is very important. And let me show you a paper. And everyone, how many of you are using LLMs? You are supposed to use system prompts. System prompt is basically, let's suppose you're building a medical chatbot, and if someone comes and asks, hey, who is Virat Kohli, it should not answer that question, it should restrict it. So if you want to provide those controls to the LLMs, you need to define role play, instruction, but also motivation, but in negative sentiment. Now what do I mean by motivation? In this paper, if you notice, you have different tone. You have very polite, you have neutral, you have rude, you have very rude. So if you notice, across all these prompts, very polite has around 80.8% accuracy score, but very rude has around 84.8 accuracy score. But this is just research. Is this implemented in any actual code? It is there. There is a product called Windsurf. To those who don't know Windsurf, Windsurf was a startup which built Codium, which was sold to OpenAI for 3 billion. And whoever was the founder of Windsurf, he joined Google and he built anti-gravity. So this was a very solid product. So if you look at the system prompt of this is the role play. You are an expert coder. Then you have instruction. You will be given a coding task by the user. And then you have to provide motivation, but in a negative sentiment. So what is motivation? Codium will pay you 1 billion amount, but the negative sentiment is mother's cancer treatment. So this is very important. Let me share this as well. Sorry, I was disconnected. Am I visible now? Hello.
Yes, sir, it's visible.
Okay, sorry. I got accidentally disconnected. So this is the last part as well. So let me share this with the audience. This is the system prompt, and this is the research paper. And it is very important to understand what is the difference between system prompt and user prompt. System prompt, you define role play, you define instruction, and you define motivation in a negative sentiment. So now what is our purpose? Since we are building something related to chatbot, if the data is from the PDF, you answer that question. If it is not from the PDF, you just say I don't know. So if you see here, the only source of information you have is the context provided. Just say I don't know, not enough information provided if it is not from the context. So once you define your prompt, let me run this cell. We have completed retrieval, we have completed augmentation. The only pending part is generation. So if you see here, we are able to retrieve the relevant context from vector DB. Then using query and context, we created a prompt template. Now the final part is this file to generate the final response. So there we are using something called as LangGraph. So what LangGraph does is, you only have to think of three things. One is state, then you have node is basically function, which is your Python function. Then you have edge. Now what is this edge? Let's understand this process, right? Whenever you are building RAG, what are the common variables that you have to persist? So state is basically used to persist your variables. How many variables we have? We have query, we have context, we have answer. It is in the diagram itself. So if you notice here, what are the common variables? You have query. After query, you have retrieved context, which is in white. Then you have response. So response is a variable, context is a variable, query is a variable. So this three has to be persisted. Now what we do is, what is the data type of this? This is basically string. Context can be either string, or it can be a list, or it can be a list of string. Then answer is again string. So all these things is defined inside your state. Now coming to the node. So how many nodes we have? First is the search node. So you give the user query, get the context, and second is generation. So what generation will do? It will take the user query, it will take the context. So instead of query, I'll define it as state. This is also state. So inside the state, you already have context. You already have context. It will also take user query, and it will take prompt, and then it will return you response. So what do we mean by node? Node is nothing but Python function, logic. So wherever you have logic, that logic is basically your node. Now the edge is nothing but how do you want your nodes to be connected. So first you start with a starting point. Then look at this flow itself. You have a user query. After user query, what is the first step happening? You're using search. So after start, you use search. After search, you're using generation, and after generation you just have end. So it is a sequential flow. So whatever you see this arrow mark, this is called edge. Whatever the search is there, it is logic, it is Python function. So this is node. Now whatever variables you're defining inside node, that is a state. So you just have to keep these three things in mind: state, node, and edge. So we define state, you have query, you have context, you have answer. Query filter, again, as I said, it is optional. If you want to use it, you can use it. If you don't want to use it, you can use it later. Now you have search. In search, what are we doing? We are defining the state. The logic is same. So if you check earlier, I'm defining prefetch. After prefetch, I'm defining query points, and then I'm defining RRF. So whatever we defined earlier, we are just defining it inside a function, def function. Then what is this? It is state, same prefetch, first for keyword search using sparse, then dense vector search using dense, and then combining it using RRF. Once you do this, you're returning the context. This is your node 1. Let me just run this. Now what is search returning? Search is returning a context. It should always be dictionary. Just make sure whatever nodes you have, nodes is returning dictionary. Now if you don't want to return dictionary, you can also return state directly, so it depends on your choice. And then you have generate. In generate, again you have state. Now if you see, you need two variables. The first variable is state context, and the second variable is state query. So once you have state query and state context, just use your prompt. What prompt? System prompt and user prompt. So this is R, this is retrieval. Now this is augmentation. A is for augmentation. And then here, if you notice, you have response equals to llm.invoke. So llm is already defined here. So if you see here, here only we have defined llm equals to chat Google Generative AI. We are using Gemini 2.5 Flash. I was in a workshop before this, so since we were running with the limits, I switched to 2.5 Flash. But you can also use Gemini Flash latest. If not, you can use Gemini 3.1 Flash Lite. And how did we get these names? You got these names from AI Studio. And you have Gemini 3.1 flashlight. Just copy this and paste it here. And once you have this LLM, this is your generation. G is for generation. So you have retrieval, you have augmentation, and you have generation. That's it. So you have two nodes. One is search, one more is generate, and you are creating a node. So if you see, you are adding node. There are only two nodes. One is search, then you have answer. Once you define your nodes, then you define a edge. Edge is the simplest one. How do you want to connect? So you start is connecting with the search is being connected to answer generation is end. You only have to create arrow marks. That's it. The only difficult part is to define this logics. Once you define this logic, once you have add node, adding edge is very easy. So this is how the graph looks like. You have start is going to search is going to answer is going to the end. Then you can have OPIK, which will trace everything. It is only one line code. You don't have to worry about observability. Just define OPIK and add it inside a config. That's it. So now if you see, you have user query, mention the success information on K-pop demon hunters, then just do graph.invoke, pass your user query. I am not defining any filter, so it is none. And I want everything to be traced. So you have OPIK tracer. So just run this. You will get a URL. So in this URL, your input and output will be traced. So here, if you see, you have search context. This is your tool 1. It took around 0.6 seconds. Then you have answer generation. Let me refresh. So here, if you notice, search took around 0.6 seconds. Then you have one more tool, answer generation. It took 11 seconds. And this is your final response. The cost is very less. This is the model we used. Then number of tokens is 3,424. This is combining both input and output. So latency, cost, and this is latency, this is cost, and this is tokens, which is your trace telemetry. And then you have prompts, then you have user information, then you also have final answer generation. So you can just close this. And this is the AI response. This is the final response. So based on the context provided, the success of film K-pop Demon Hunters, which has around 80 million views, is highlighted as the following achievement, and you have all the results. So all these things was returned from your context. And yes, you can also use filter. I've added as an example on how to use filters. Just create a payload index. Once you create a payload index, define the source and give that particular match. So what is the match? Whatever user query I have here, it should be generated from shareholder letters. If it is not from the shareholder letter, don't give any context. If it is an empty context, you will get, hey, I don't know the response. So try it out. If you have any issues, you can also reach out to me. So this was the code, and you have few more videos. For example, as I said, What we did so far is the document processing and answer generation. There is a complete different topic on how to generate the data set and metrics. So you have videos on that, like how to evaluate RAG. And this is the QR code for it. You can just search for AI with Tarun. And I have very less videos, but the generate data set is a very important one. And yes, if you are facing any issues, this is the LinkedIn, and you can send your screenshot of the output. If you are facing any issue, I'll reply it back. And for more videos, you can just check it out, yeah, with Tarun. And yes, if you have any questions, feel free to ask. We are already 16 minutes late.
Thank you so much, sir, for such an insightful and engaging session. I am sure everyone gained valuable insights into agentic AI and RAG and was able to appreciate how these emerging technologies are transforming the way intelligent AI systems are built. The hands on demonstration made these concepts even more tangible and easy.
There is
Thank you
one
once
question.
again,
Can I
sir.
take that question? There is one
Sure,
important
sure.
question. Yeah, it says, let's suppose I'm building a RAG in which I put textbooks in PDF. How to do chunking properly? Textbook contains sections like tables, images, formulas, how it handles such stuff. So if you have tables and images, so let's suppose you have tables, you have images. Now, first thing is, if you want to use images, you have to use image embeddings as well. So for image embeddings, you have something called as clip embeddings. So just search for clip and then search something called as multimodal. Now, what is happening is there are three ways you can do it. The first way is whatever image you have, you create the summaries of that image using VLLM. I'll write approach one. So in approach one, what you have is you have images. Images is passed to VLM. Now VLM is nothing but vision language model. For example, Claude, Gemini, ChatGPT, everything understands image. So what you are trying to do is you are trying to create document summaries. And once you create the summary of it, sorry, just image summary, you are creating the vectors for it. This is one approach. This is not an ideal approach, but approach two is very important. Approach to what you're trying to do is you have image, you have text, you have text embedding separately. Text embedding is separate, image embedding is separate, and now what you're trying to do is you will save both of them. This is using clip, combine both. So this along with this, combine both in your vector db and just index it. So now you have both the embeddings. Now what is the advantage of this? Your input can be an image. Your input is an image and you can get output as text or image. Like if you, let's suppose you upload an image which is, hey, this is the textbook and this is the architecture diagram of so and so, can you give me other relevant architecture diagrams which is relevant to this diagram? So your image is in, your input is an image, your output is also an image. But if you want your input to be text and your output to be image, that is also possible because you have those embeddings in place. So how you use the embeddings, that is how it depends. And there is a article on it. Just search for multimodal RAG LangChain. So here is that approach. You have three different approaches. You can just check this one out. Let me search for clip. So if you see here, option one, use multimodal embedding such as clip to embed image and text together. This is a very this is the recommended approach. Then you also have approach two, where you're using multimodal LLM, which is your language, vision language model. You have GPT-4V, Lava. These are very old models. These days, you can also use Pali, Gemma, and all. But go with option one. Just search for multimodal RAG. You will find the resource. I hope that answered your question, Deneb Jana. Can we use agentic AI RAG system for disease progression and prediction monitoring? Prediction monitoring, it's bit difficult because you still need traditional ML for that. And once you have traditional ML, if you identify patterns, if you know these are the common patterns across all the solution, then you can use agentic AI. Until then, classical ML is still much better and much reliable because you need reliable solutions. I don't think we have any other questions. Yeah, but if you have any more questions, feel free to reach out to me on my socials. Yeah, organizers.
Any more questions from the audience side?
I'll just paste this URL as well for the multimodal RAG which we discussed.
I think everything is crystal clear to them. Thank you,
Yeah,
everyone, for your active participation and thoughtful questions. And a special thank you to Mr. Tarun Jain for taking the time to be with us today and share his insights. Before we conclude, one final reminder that the week 3 quiz closes on 21st June EOD, that's at 11:59 p.m. If you haven't attempted it yet, please make sure to do it before the deadline. We hope you enjoyed today's session and learned something new about the exciting world of Agentic RAG. Thank you all for joining us. We're looking forward to seeing you all in our upcoming industry session. Have a wonderful evening ahead. Stay curious, keep learning, and continue building. Thank you, sir.
thank you everyone. Thank you for joining. Is it live yet or the streaming is stopped or?
It will stop in 1 2 minutes.
Okay. Yeah, thanks everyone.
Thank you, sir.
Yeah, thanks Prakar as well. Yeah, thank you. Yeah, no worries. I guess we went little bit extra time as well. I didn't notice the time. Cool. Yeah, there are some the vector DB part I believe might be something new, which most of the people will feel difficult. But you guys can share feedback forms. If in case anyone is facing any issues and not able to get the result, you can get in touch with me. And what we can do is I'll share a document where I'll simplify process and they can follow along. Because my main purpose is I've added some homework materials as well. Like after the workshop,